everyone, this video is on zeros and multiplicity. Given a graph, we're going to find the zeros, the factors, we're going to write the polynomial, and we're going to review some facts about polynomials. Stay tuned. Here is a graph, a polynomial graph. You'll notice that it's in behavior, shows that on the left it is going up, on the right it is going down. So this is going to be an odd degree. All right. So let's talk about the x-intercepts. The x-intercepts are the places where the graph crosses the x-axis. And if you'll notice that, it is at -3, -1, 2, and 4. Okay? And then we'll notice that if we want to write the factors for that, we would say x plus 3, x plus 1, x minus 2, and x minus 4. And those would be the factors for those zeros. And so then the polynomial would be f of x equals, now notice that at -3 it's a cross, it crosses. At -1 it's a bounce. At 2 it's a wiggle. And at 4 it's a cross, right? So if we put the exponents in then, at -3 it's a cross, so that would be a 1. At -1 was a bounce, so that would be squared. A wiggle would be to the third, and the other would be, now you don't have to put the ones, but that's what those are. So if you added that up, that'd be 1, 2, 3, 4, 5, 6, 7. This is a 7th degree polynomial. A 7th degree polynomial. So if you're writing the polynomial, it would look like this: x plus 3, x plus 1 squared, x minus 2 to the third, x minus 4 to the first, or just leave it like that. The multiplicity then, this would be a multiplicity of 1, multiplicity of 2, multiplicity of 3, multiplicity of 1. Multiplicity just means, does it cross, does it bounce, does it wiggle? And so that's what you're looking for. So let's review this. These are the repeated zeros of a polynomial. All right, so you can see here that when the polynomial crosses at the 0, then that means that the factor has a multiplicity of 1. So since it crosses at 3, we wrote the factor as x minus 3 to the first power. So this is a cross. So you can see here at this 0, we have something that looks like a bounce. Right? So when it bounces here like this, just like this, then this would also, the factor, the x-intercept is at 3, the factor is x minus 3 quantity squared. So you would say that this real 0, it's real because it's on the x-axis, the real 0 has a multiplicity of 2. Now the third example with the multiplicity of 3 is like a wiggle. And we call it a wiggle because it's descriptive that way. But you can see it kind of flattens out near the x-axis. It's a cross. It does cross there, but it flattens out. So the flatter it is, the more odd it is. So like for instance, this is to the third. If it's really, really flat, sometimes it could be to the 5th. You don't see those very often. But you would see this. It would be a factor of x minus 3 times x minus 3 times x minus 3, or x minus 3 to the third power. So if you were counting, there would be 3 real zeros. They would count it as 3 real zeros because it's a wiggle there. So it has a multiplicity of 3. The 0 is at 3, multiplicity of 3. Okay, so this graph, and it's a little bit cut off, but you can see it. The following graph shows an 8th degree polynomial. List the polynomial zeros and their multiplicities. Okay, so I'm looking here. There is a 0 at -15, and it is a cross, so its multiplicity is a 1. There's another 0 at negative 10. And that looks like it goes up to it, comes back down a bounce. So that's a multiplicity of 2. There's another 0 at negative 5. It's just a basic cross. There's also a cross at 0, so it has a multiplicity of 1. Then it comes to 10. 10 is a bounce. And you can see, so that's going to be a multiplicity of 2. Multiplicity 0, right? And then the last one is 15, and it crosses at 15, so it has a multiplicity of 1. So hopefully if we add these up, 3, 4, 5, 6, 7, 8, this is going to be an 8th degree polynomial. All right. Another thing is you can count the turning points. So I've got 1, 2, 3, 4, 5, 6, 7. So there are 7 turning points in an 8th degree polynomial. Okay, so here's a recap, and you need to have this in your notes. A polynomial of degree n, any degree n, can have at most n zeros, n factors, each factor corresponds to a 0, n x-intercepts, and it will have one less than its degree turning point. So what this means is that a polynomial of degree 5 can have at most 5 zeros, that is 5 factors, 5 x-intercepts, and at most 4 turning points. And so that's how all of that relates together. So we're going to be practicing this a lot in class. So be sure that you at least have the fundamentals here, and if you have any questions, be sure to bring those up in class. And I'll see you then.